In the diagram shown below, ABE is a tangent to the circle centre O, angle DBE is 58 degrees. All that information is on your diagram. Now, there is really important points here. A tangent is a line that meets a circle at one point, and there's your tangent there drawn in a pink colour. Now, the important thing here is that a tangent and a radius meet at 90 degrees. So I've drawn in the radius coming from the centre out to that point of contact. So that means that that full angle in there is 90 degrees. So they're giving me a wee starting point by saying, if that angle in there is 58, what angle can I work out? And there is only one that I can work out just now, and it's this angle in here. So that angle in there has got to be 90 degrees, take away the 58 degrees. And 58 away from 90 leaves me with 32 degrees. So I can fill that into the diagram. So that one there is 32 degrees. Now, when you have a circle and you have triangles drawn and one of the points is coming from the centre, there's one there. That's a radius in yellow, but that's also a radius there. So that means that that's an isosceles triangle. So an isosceles triangle, the two base angles are exactly the same. So that angle in there is also 32 degrees. Now, what's the only thing I can do now? I've got a triangle. I ultimately want to get this angle down here, but I have to piece all the evidence together. So the only thing I can do is work out this one in here. So to get that one, we know that the angles in a triangle add up to 180 degrees. So I've got 180 degrees, and I've already used up 32 and 32, which is 64. So I'm going to take the 64 degrees away from 180, and that leaves me with 116 degrees. So that one in there is 116 degrees. Now, I want this one in here. Okay, so I'll change that into the blue one. There is a straight line going from there right the way around to there. A straight line adds up to 180, so I've got 180 degrees, and I want to take away that 116. It's connected to the one above. The answer is 64 degrees, so I can fill in 64 degrees in there. Now, where do I go from there? If I look here, there's the centre, there's a radius, there's another isosceles triangle. So the angles in an isosceles triangle add up to 180. That one is going to be exactly the same as that one. So that one and that one are exactly the same. So I've got 180 degrees, and if I take away the 64 that I've already used, so I've used that 64 away, so whatever I'm left with, I'm going to share it with those two. So when I take 64 away from 180, I'm left with 116. But I want to share that 116 with the two angles that I've got. So 116 divided by 2, and that gives me 58 for both of those angles. So that one there will be 58, and that one will also be 58. Right, I'm getting closer to getting to this triangle. So the next thing I want to do is, I can work out this one. So this one on here, I'll go back to red. This one on here, those two angles add up to 180. So if I take 180 and I take away the 58, then to find out the one that's at the other side, I've got 122 degrees. So in there is 1, 2, 2. Now in this triangle here with the angle that's missing, I've still only got one angle. So I really need to get this one in here. There again, there's the radius, there's the tangent. The angle between the radius and the tangent is 90 degrees. So therefore, I'll get my 90 degrees, and I want to take away the 58 degrees. And when I take 58 away from 90, I'm left with 32 degrees. So that one in there is also 32. Now, I've got this big triangle with the angle that I want to find. And I'm going to call that angle A. So to get angle A is equal to, we start off with 180 degrees. And I want to take away the two angles that I've got, which is 122 plus 32. So I've got 180 degrees, and I want to take away 154. And 154 away from 180 leaves me with 26 degrees. Now clearly make sure your answer is written down, because there's lots of calculations there as you go around that diagram. Now that is not the only way you can do that question. When I got to this wee bit, I could have worked in that part, and then going from there. So you work through it, make sure you can do it, but the important points are isosceles triangles, a tangent meets the radius at 90 degrees. That's the whole crux of this question. If you don't know those facts, then you will not be able to do this question. Your isosceles triangles come from the centre and they go out to the circumference, and there's another one out to the circumference. So the angles out at the circumference are always the ones that are equal. And then you're just looking for straight lines, and you're looking for your right angles for your tangents. Right, so we want to change the subject of the formula to b. So b is on the right hand side, so I'm going to write the whole formula around the other way. So t squared plus 4b all divided by c is equal to f. So I'm just reading it round the other way, I've not done anything. Now that b is stuck in here with this 4b, so that's going to be the last thing that you crack, that's the last thing you do. So if we read this side out, we've got t squared plus 4b divided by c. The last thing I said was divide by c, so that's the first thing I've got to get rid of. So I multiply both sides by c. So when I multiply this side by c, I'm left with t squared plus 4b, the c's cancel, and I get f times c. The next thing I want to do is I want to get rid of this t squared plus. So what's the opposite of adding on t squared to something? It's taking away t squared. So I take t squared away from both sides. That leaves me with 4b. Now I'm taking t squared away, so it's fc is already there, and I'm taking away t squared. It's logical. The next thing is 4 times b is equal to that whole thing. I don't want 4 times b, so the opposite of multiplying by 4 is to divide by 4. Now make sure you do one big line because you're dividing everything in that whole side by 4. So one great big division line right across and divide it by 4. And then your final answer, make sure you underline it clearly. Express 3 over a squared minus 2 over a as a single fraction in its simplest form. So the first thing we do when we have got a fraction, we find our common denominator. Now you always check, the smaller one, can it divide into the bigger one? Yeah, in this case it can. So therefore my common denominator is actually a squared. Okay, so I'll write down a squared for each of them. Now I then look to see what I've done to each fraction. So have I done anything to that? Not really. You could say I've multiplied it by 1, but it stays exactly the same at the top. Now what have I done by a to get a squared? I've multiplied by a. So I've got to be fair with fractions, so I multiply the top by a, so I get 2a at the top. Now once I've done that, the only thing left to do is to express it as one fraction, so a squared stays at the bottom, and at the top I've got 3 minus 2a. Can't add them or subtract them, they're different things, so it stays as that. Now if you don't spot that your lowest common denominator is a squared, you will do a squared times a and you will get a cubed. Right, that's okay, right, so there's your a cubed for each of them. Now then you would look and you'd say, right, what do I do to a squared to change it to a cubed? I multiply it by a. So do the same to the top, keep the fractions fair. So 3 times a is 3a. Do the same thing here, a multiplied by what gives me a cubed, I've got to multiply by a squared. Do exactly the same to the numerator, keep your fractions fair. So it's 2a squared. I've now got the same denominator, so I can simply add or subtract the numerators. And when I do that, I get 3a minus 2a squared divided by a cubed. Now up here it says simplest form, that's not in its simplest form. So if you look at that top line there, you can take out a common factor of a. So it's a bracket 3 minus 2a, and that's all divided by a cubed, and then you cancel an a from top to bottom. So effectively you do get the same answer, but I did that in 2 quick steps. Look at all the steps you've got to do for that one, so it's worth checking to make sure you've got the lowest common denominator. And do that wee check, does the smaller one divide into the bigger one? If it does, that is your common denominator. Right, next question. It says gym members are asked to provide or to fill out a questionnaire to rate the quality of service provided. They are asked to give a rating on a scale of 1 to 6. The ratings given by 5 members were as follows: a 1, a 4, a 6, a 3 and a 6. It says in its simple form, the standard deviation of these ratings can be written as find the values of A and B. Now that looks more complicated than it really is. You're focusing on this thing here where you have to work out the standard deviation. So forget that wee bit just now at the end. We'll come to that when we've worked out the standard deviation. So the first thing we do is you get your standard deviation form from your information sheet. Now, standard deviation is the square root of the sum of x's minus x bar all squared divided by n minus 1. Sum just means you're adding them all up. X are all those numbers there, and x bar stands for the mean. N is the number of numbers you've got. Now, to guide you through this calculation, you do a table. And once you've done the table, table's straightforward. Once you've got your table, then it's easy to put the numbers into that formula and it doesn't look quite as complicated as it is. So the first thing we're going to do is we're going to work out x bar, which is the mean. So when I'm working out the mean, I'm taking all of these numbers here and I'm adding them. So it's 1 plus 4 plus 6 plus 3 plus 6, and all of that is divided by 1, 2, 3, 4, 5 divided by 5. Now the answer to that then gives me, when I add them all up, I get 20 divided by 5, so x bar is equal to 4. Now the next thing you do is you set up a table. Now you're guided by this table because you're writing down these numbers first of all. So make a wee table like that. The first thing that goes in there is x. You want to know what your numbers are. So you've got 1, 4, 6, 3 and 6. Now what's the next thing you need to know? You need to know these x minus x bars. So your next line in the table is x minus x bar. So be guided by that formula. But I don't just want to know what they are. I want to know what they are squared. So your last line in the table is x minus x bar all squared. Now we know that x bar is 4. So that wee part in there is going to be 1 minus 4. That's going to be 4 minus 4. That's going to be 6 minus 4. That's going to be 3 minus 4. And that's going to be 6 minus 4. So I've just written them down and I'll now go and put the answers in. So first one, we have got 1 minus 4 gives me a value of, I'll choose colour so it sticks out, so I've got minus 3. 4 minus 4 is 0. 6 minus 4 is 2. 3 minus 4 is minus 1. And 6 minus 4 again is 2. So we take all of those numbers and we square them, and we're really squaring them to get rid of the negative signs. So minus 3 squared is 9, 0 squared is 0, 2 squared is 4, 1 squared, or minus 1 squared is 1, and 2 squared is 4. Now we check if you add up your negative numbers on this side, so minus 3 and minus 1 is minus 4, and you add up your positive numbers, 2 and 0, 2, 0 and 2, if you add them all up, they should be the same value, so 1 is minus 4 and 1 is plus 4. That's how we checked to make sure you've not made a mistake. Okay, so always do that. Now the next thing I want then is, I want to add up all those numbers. Okay? So when I add up all of those numbers there, that's giving me the sum of x minus x bar all squared. And when you add up that last column, you get 18. Now that just lets me then put it straight into the formula. So the formula here is, and all I have to now do is to put the numbers into that formula. So it's the square root of 18, and the number of numbers was 5, so that's going to be divided by 4. Now at this stage you can split that root sign, so it's the same as the square root of 18 and the square root of 4. Now we know the square root of 4 is 2, so I'll write that in just now. Now, is there a square number that divides into 18? There is. 9, so that's the same as the square root of 9 times by 2. Break that root sign, so you get root 9 times root 2 divided by 2. Now what is the square root of 9? It's 3, so it's 3 root 2 over 2. Now compare it to the answer up here. A root b over 2, so we've got over 2, so all I have to now do is to show that a is 3 and up here b is equal to 2, and write that down clearly. So a is equal to 3 and b is equal to 2, and underline your answers. So it's just a straightforward standard deviation question, but you can see at the end we're really changing this answer and we're using our surds. Okay, so that's another case where your questions test more than one topic, and that's why it's so important that you do all of the past paper questions that you can. The graph below shows two straight lines with equations 3x minus y is equal to 2 and x plus 3y equals 19. The lines intersect at the point P. Find algebraically the coordinates of P. Now basically we're solving simultaneous equations. When you solve two simultaneous equations, you find out where two straight lines cross, because each of those equations are the equations of a straight line. So we're really finding out where they cross. So we'll start off with equation 1. So we've got 3x minus y is equal to 2, and I'm going to label that as equation 1. Then we've got x plus 3y is equal to 19, and that's equation 2. Now, I can multiply equations by any number as long as I do the same thing to everything, every term in the equation. It'll stay balanced and it's okay. So the aim of this is I can't solve an equation that's got two letters in it, it's got two variables, two unknowns. So what I've got to do is I've got to get the equation so that one of those letters disappears, they cancel. So I'll look at the letters, that's 3x and that's just 1x. And I'll look at this one, y is minus 1y and plus 3y. So that's the best one to cancel because one is positive and one is negative, and when they're added they will cancel. But the problem is I really need that to have the same numerical value. I need to have that as a 3. So what I can do is I can take equation 1 and I can multiply it by 3. So when I do that, I'm getting a new equation. Now be careful that you multiply every single part of that. So 3 times 3x's are 9x, 3 times minus y is minus 3y, and 3 times 2 is 6. Now that's a new equation, that's equation 3. Now what do I want to do? I want to add on this equation. So write it underneath it, x plus 3y is equal to 19. So really what I'm doing here is I'm adding equation 3, new one, and equation 2. Always write down your instructions. Don't have a big page of x's and numbers because the examiner will not be able to find out what you're doing, so make sure you explain what you're doing. Right, so the last thing left to do then is to add those equations. So 9x's plus another 1x gives me 10x's, and minus 3y plus 3y, they disappear, that was the whole point of it. 16 and 19 is 25. So therefore, from that, if I want 1x, x is equal to 25 divided by 10, which is 2.5. Now, lastly, I've now got to sub x equal to 2.5 into one of the equations. Now, which one am I going to choose? I'm going to choose one that I've not changed in any way. Don't go to one that you've multiplied, you go back to one of the original ones. I'm going to choose this one here because it's got a straightforward x in it. So I've got x plus 3y is equal to 19. Most of the time it doesn't matter which one you choose, and it still all works. Right, so x is 2.5 and I've got 3y, and that's all equal to 19. So don't want that 2.5 there, so take 2.5 away from both sides, and when I take 2.5 away from 19 I get 16.5. So y is equal to 16.5 divided by 3. 3 into 1 won't go, 3 into 16 goes 5 times and 1 left over. 3 into 15 goes 5 times, so it gives me 5.5. Now at this stage here, go back and read the question. Always go back to your question. Find algebraically the coordinates of P. If I leave my answer the way I've got it just now, I will not get that final mark because I was asked to work out the coordinates of P. So the coordinates of P are going to be the x coordinate first, so it's 2.5, and the y coordinate next is 5.5. Now for one full mark, I've just had to write down those coordinates. If you do all of that and you don't write that, you will not get 3 marks, you will only get 2. So a 1 full mark for doing that, so please be tuned into what you're doing and make sure you write everything down. The graph below shows a parabola with the equation of the form y is equal to x plus al squared plus b. So this is your completed square. Now from a completed square, to work out what the turning point is, you take the value inside the bracket with the x and you change the sign because you really want that bracket to be 0. So the turning point, the x coordinate, has got to be minus a, and you just read off the y coordinate from the bit at the end. So that's the background behind that. Now we have got 1 point on the graph, and I'm told that the axis of symmetry is in the line x is equal to -5. So there's the turning point there, so that means that has got equation -5 something. Okay, don't know what that something is, I don't know where it is, it's going to be below 8. Right, so first part it says state the value of A. So if we compare that, right, so I've got a turning point that I know part of, and I know part of it is -5 something, don't know what that is. Then all I want just now is the value for A, so compare the both of them, and A has got to be equal to 5. Now for the next part, it says the point the -3, 8 lies in the parabola, so you've got to calculate the value of B. Now what do we know so far? Right, so if we go back up to that equation there, and we put in our 5, so I've got y is equal to x minus 5 all squared plus b. So y is equal to, and read off your equation, it's x plus a all squared plus b. Now when I do that, then I've got to substitute in the point -3, 8, and I know that that's x, and I know that that one there is y. Now I've also worked out the value for a, so it's x plus 5 all squared plus b. So fill that in first. Right, we're now going to put in the y coordinate is 8, so 8 is equal to x is -3, so it's -3 plus 5 all squared plus this value b. In maths, always do your brackets first, so 8 is equal to -3 plus 5 is 2, 2 squared is 4, so to work out what b is, I know from that 4 plus b, reading it round the other way, is equal to 8, so therefore b is equal to 8 take away 4, which is equal to 4. Now right at the end, write down both answers, a is equal to 5 and b is equal to 4, and underline your answers. In the diagram below, we're given various lengths of lines. We're told that 2 lines are parallel, and we're told that the length of P to S, that bit here, is x centimetres, and we've got to calculate x. So first thing I do is I draw down the 2 separate triangles. Okay, so there's a wee triangle there, and then there's the overall big outer triangle. So I'm going to draw them down and I'll label them. So that's P, that's T, and that's S. That one there is P, the outer triangle, that's Q, and that one is R. Now once you've done that, fill in everything you know. So I know that this side here is 5 centimetres, and I know that this one is 7 centimetres, and I know that across there is x, and I know that across here is the distance right the way across there, so it's x plus 2.6. Now this is one of the hardest simultaneous equations, or sorry, hardest similar triangle equations that you can be given. Okay, it's a very difficult question to do. So stick to the rules, stick to everything that you know. In any of these questions, you would firstly work out the scale factor. Now what is the scale factor? Scale factor K is shape 2 divided by shape 1. Now this one's more complicated because x is in both triangles, but we'll see where this takes us. So shape 2 is 7 and 5. So we've got 7 divided by 5 as our scale factor. Now you can change that to 1.4, but this is a non-calculator paper, so I would advise you leave it as 7/5. Now what does that mean? That means that everything in that triangle is multiplied by 7/5 to get to the other one. So these are the things that I want to work out, so I'll just stick to that wee principle. So I'll take that side there, so I'm going to take this x, and I'm going to multiply it by the scale factor, and I know that that's got to be the answer. Okay, don't know how it's going to turn out just now, but that's what you do. So x multiplied by 7/5, and that would give you the long side here, PR, which is x plus 2.6. Okay, now if I tidy that up, that means 7/5 x's is equal to x plus 2.6. Now suddenly this question in similar triangles is changed into an equations question, and this is what will happen at the end of your paper, so you've got to be confident that you can work with all the things that you've done. Right, I don't like that dividing by 5, I don't like that fraction, so I'm going to multiply everything by 5. So when I multiply all of this by 5, I would really get 35x over 5, which brings me back to 7x. It cancels the 5. Now all of this side has got to be multiplied by 5, and because there's more than one bit, I'm going to put in a bracket. So that gives me 7x's is equal to, and when I multiply all of this out, I'm getting 5x's, and 5 times 2.6, 10 times 2.6 is 26, but I only want half of that, so it's plus 13. If you cannot do that, you work it out at the side of your page. Now, that's a straightforward equation. I can take 5x off both sides, so it comes away from there, and it comes away from there, and that leaves me with 2x's equal to 13. I don't want 2x, I only want 1x, so x is equal to half of 13, which is equal to 6.5. Now, it's really important when you're given questions like this, you will not always know where it's going. You start by doing the basics of what you've been taught, because you will be applying the knowledge that you already have. And if you take your time and you get everything down on paper that you know about that question or that topic, then sometimes it just leads, and then you can get the next step, and you get the next step, and then you can solve it. And that's the important thing, that's your exam technique where you're picking up marks, because some pupils will look at questions and they'll say, I don't know how to do that, I've not seen that before. You will not have seen every question that you're going to get in your exam, but you will know how to do the tools, the maths behind them all, and you have to hold your nerve and you have to apply all of that knowledge one wee step at a time, and it'll unravel until you get it.